the final thing that's needed for merit here is just a comparison of this gradient that we've obtained here with our uncertainty and theory. Okay, so we just need to state what the theory is. Go back to size 11 here. So, according to theory, the relationship between the period and the mass suspended from a spring is given by, and then this is the equation that was given on the task sheet, so we'll go new equation, t equals 2, and then Greek letters, pi, and then square root, and we want a fraction in here, and that's m over k. Oops. K. Okay, that's the theoretical equation. This means that our gradient, or in fact what we can say then is the spring constant of the spring we used was stated to be approximately 25 newtons per meter. Okay, and if we plug that in here, what gradient ought we to get here? So if you look here, you can compare t is equal to something times square root m. That something must be equal to our gradient. So if we compare the theoretical equation with our experimental one, we see that and then we'll go new equation, and we can say experimental gradient should be equal to 2 pi times 1 over, oops, I just lost my place, 1 over square root k. Okay, and then we'll center that. So in other words, because in theory, 2 pi over square root, 2 pi times 1 over square root k times m should be the period. In our experiment, we had the period is this times square root m. So that, in other words, this here must be equal to this here. Okay. So if we compute what that is, we get 2 pi times 1 over, how do I keep doing that? 1 over square root 25 equals, we'll just calculate that, 2 times pi times 1 over square root of 25 is 1 over 5, which is 0.2, is 1.26. Seconds per square root kilogram. Our experimental value is 1.3. Well, I'll just copy it from here. So 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 the theoretical value falls within our experimental uncertainty. Okay, so just to recap what we've done here, I found the relevant equation, which was given on the sheet, and the relevant data, which was also given on the sheet. And then if we rearrange this slightly so we get t is equal to some constant times square root m, we can compare that constant with our experimental gradient, because t is some constant times square root m is also what we got from our experiment. And when we compare those constants, we see that one is 1.26, that's the theoretical one, and one is 1.3 plus or minus 0.1. And 1.26 is only 0.04 less than 1.3, so it falls within our experimental uncertainty, which ranges between 1.2 and 1.4. Okay, so that's how we do the comparison.